Hi students, in this video we will be solving question number 6 from the exercise 10.3 of the chapter Straight Lines, and this is a first PU syllabus. If you go to playlist and look for straight lines, in that folder you will be able to find all the sums and derivations related to this chapter. Now let us check question number 6. Find the distance between parallel lines. We are given two parallel lines and we have to find the distance between those two parallel lines. And there are two sub questions in this. So let us solve the first sub question now. These are the two parallel lines. Look at the equation, children. How are the equations of parallel lines? If you check, the x and y term will be same for both the equations. Do you see that? Yes, x and y term will remain the same. Only the c terms will differ. This is minus 34 here and this is 31 here. So, equations of two parallel lines always differ by their constants. The x and y terms will remain the same. So, whenever you come across such equations, always identify, or you can easily identify that they are equations of parallel lines. They differ only by their constants. The x and y terms remain the same. Is this clear? Okay. Now let us say these are the two parallel lines, and distance between them, from here to here also you can call it as distance. From here to here also you can call it as distance between two parallel lines. But the actual distance is always the perpendicular distance is the shortest distance. That is the actual distance. Okay. So you draw a perpendicular from any of the lines and that will be again perpendicular to the other line also. So that perpendicular distance is the actual distance. That will be the shortest distance and that is the actual distance between two parallel lines. We have already learned the formula to find the distance between two parallel lines when the lines are ax plus by plus c1 is equal to 0 and ax plus by plus c2 is equal to 0. If the equations are like this, then the distance between them is d is equal to modulus of c1 minus c2 whole divided by square root of a square plus b square. Now, you can see how have we taken the standard or the general form of the equation. It is like ax plus by because those two terms are same, no? So, we have taken ax plus by. It differs only by their constants c1 and c2. That is why we have taken only these two terms as c1 and c2. A and b as a and b only, not as a1, b1, a2, b2. Clear? Okay. Now comparing this standard form to the given equations, we'll find out a, b, c1 and c2 values. A is 15, b is 8 and c1 is minus 32 and c2 is plus 31. Here if you interchange c1 and c2, it does not affect the distance. So whichever value you want, you can take as c1 and c2. After finding these values, it is just application of these points to this formula. Let's do it now. D is equal to modulus of c1 minus c2, which will be minus 34 minus 31 whole divided by square root of a square. A is 15, so 15 square plus b is 8, which is 8 square. So on simplification, we get the distance to be d is equal to modulus of minus 65 divided by square root of 225 plus 64. So when we further simplify it, it is d is equal to modulus of minus 65 by square root of 289. You know the 289 is the square of 17. So our term will be 65 by 17. Since this is the distance and a modulus is already considered, we are only considering the positive quantity. Because this is a distance, we are not considering the negative sign. So we have taken the modulus here or we have applied the modulus here. So the distance will be 65 by 17 units. Is this clear, students? Now let us check the second sub question. The equations of the lines are given like this. It is L into x plus y plus p equal to 0, L into x plus y minus r equal to 0. These are the equations of parallel lines. Here again you can compare and see L into x plus y, that is x and y terms are same. It only differs by their constants. So these are the parallel lines. Distance between them, as I told you, is the perpendicular distance. or that is the shortest distance, which is D. So we already have learned a formula to find the distance between two parallel lines, which is D is equal to modulus of C1 minus C2 whole divided by root of A square plus B square. Now you can see that it is not in the general form, right? We will just multiply and open the brackets and bring it to general form. That we have to do before comparing, okay? If you can identify the form and directly write, it is absolutely fine, but it is always advisable to write it in the general form. Then proceed. Okay, Lx plus Ly plus P equal to 0 and Lx plus Ly minus R is equal to 0. Now you can see it is in the general form. Then compare and get the values of A, B, C1 and C2. So comparing gives us A as L, B as L and C1 is P and C2 is minus R. You can compare it here. Now we know that A and B both are equal to L only in this case, okay? So we have to apply these values to the formula. That's it. So it is D is equal to modulus of P minus of minus R whole divided by A square plus B square. Now we know that A and B both are equal to L. So it is L square plus L square. So this will be D is equal to modulus of P plus R whole divided by root of 2L square. We know it is L square. So when it comes out of the square root, it will be L. So it is D is equal to modulus of P plus R divided by L root 2 units. Now the numerator is a positive quantity because there is modulus. In the denominator, L square comes out of the square root and it becomes L, and we have not considered the plus or minus because this is the distance. We have considered only the positive quantity, so we have written L only in the denominator. Is this clear? Why did we not consider plus or minus? Because it has come out of the square root and we have not written plus or minus. Why did we ignore that negative sign? Because it is the distance that we are finding. So our distance will be D is equal to modulus of P plus R divided by L root 2 units. Hope it is clear, students. If you still have any doubt, please do mention it in the comment section.